I'm Anil Kumar. As a part of review of calculus application of derivatives, here is a very interesting question. You need to find equation of tangent to the curve represented by y equals to x plus ln x that is perpendicular to 3x plus 9y equals to 8. I would like you to pause the video, answer the question, and then look into my suggestions. Now, when we say that the line is perpendicular or tangent line is perpendicular to a given line, that means their slopes product is -1, right? So let's find the slope of the given line. 3x plus 9y equals to 8. We can rearrange 9y equals to minus 3x plus 8. Y equals to minus 3 over 9x plus 8, or y is equals to minus 1 over 3x plus 8. So this gives you slope of the line as minus 1 over 3. So what is going to be the slope of perpendicular line? That is going to be 3, right? So when you multiply these two, you do get 1, minus 1. Okay, so we know that the slope of the line should be 3. Now we need to find equation of tangent to this curve, right? So let's find derivative, and then we'll actually equate that derivative to the given slope. So the function is y equals to x plus ln x. So dy dx will be equal to 1 plus derivative of ln x is 1 over x. Now, we know that the derivative represents the slope, and therefore 3 is equal to 1 plus 1 over x, or 3 minus 1 equals to 1 over x, which is 2, right? Is 1 over x, or x is equals to half. Correct? So x is equal to half. Now if x is half, then what is the point on this particular line? Now let's calculate that. So we got the x coordinate, correct? Y coordinate we can calculate. Y equals to x plus ln x. Let's substitute half. So we get y equals to half plus ln half. Now what is ln half? We could write this as ln 1 using properties. You could write 2 to the power of minus 1 also, but we are using properties now. Minus ln 2. ln 1 is 0, so we can write y equals to half minus ln 2. Right? So when x is half, y is half minus ln 2, or the point is half, and this value here is half minus ln 2. So that becomes the coordinate of our point. We know the coordinate of the point, we know slope, we can always find equation of the line. Is that clear? So let's find the equation of the line now. So equation of the line, we can use the formula. Let's do it here. We'll write down the formula at least, and then we'll work on it, right? So we can write y minus y1 equals to m times x minus x1, where x and y values are known to us. X equals to half and y is equals to half minus ln 2, right? So we are going to substitute these values and write down the equation in standard form. What I'm trying to say is x1 and y1 are these values, correct? So, and m, the slope, is equals to 3. So when we substitute all this, we get, let me draw a line here. Okay. So what we get here is y minus y1, which is half minus ln2 is equal to, slope m is 3 times x minus half. Now to get rid of fractions, I'll multiply everything by 2, right? Or we can do it later also, but we can multiply everything by 2. So what we get here is, if I multiply everything by 2, I get 2y minus, multiplying this by 2, we get 1, open the bracket, so we get plus minus minus, 2 ln2 is equals to 6, right? 6 x, right, open the bracket, minus, when you open this, 6 times 1 divided by 2 is 3. Okay, so that is what you get. Now we can reorganize, bringing all these terms to the right. So we get 0 equals to 6x minus 2y. We already have minus 3. Bring 1 here, we get plus 1 minus 2 ln2, right? So that gives us 0 equals to 6x minus 2y, the constant here minus 2, and minus 2 ln2. Is it okay? So that becomes the equation of the line. So let me rewrite this equation as 6x minus 2y. We can take minus common. 2 plus 2 ln2 equals to 0. So that becomes the equation which is tangent to the given curve and is perpendicular to the given line. So I hope the concepts are absolutely clear. Feel free to go through this explanation once again, try to understand. If you like, I hope the steps are absolutely clear. Feel free to go through this, write your comments, share my videos, and if you like and subscribe, that'll be great. Thanks for watching and all the best.